Good morning, everyone. Welcome to the webinar from TriStar. Today it's going to be the ANSYS AIM product. My name is Thiagu Palaniappan. Today's topic is going to be on the ability to use ANSYS AIM's process templates, as well as how to, or some of the customization options available within ANSYS AIM that allows you to customize and create your own templates. And for those who have not seen ANSYS AIM, I'll just do a quick overview and just to stress the importance of simulation up front early in the product development process. So ANSYS AIM is a product that's created for every engineer to do simulation, right? So that's what we're going to talk about in this webinar. Now, please note that all of you are muted in this webinar. We will be recording this entire webinar, so if one of your coworkers or if you yourselves couldn't attend the entire webinar, please feel free to check out the recordings that's available in our resource center. And also feel free to start typing in your questions. I'll try to get towards the end in about 30 minutes. We'll do a half-an-hour presentation here, and towards the end, I'll try to get to your questions, and I'll try my best to answer those. So before we get to the agenda, I just wanted to spend a couple minutes here on some of the promotions we have. It's a time-limited offer, wherein if you could please register for these webinars, upcoming webinars, you could see if you qualify for a 21-day free trial license of AIM with full support from the ANSYS experts, right? So, and also there is an offer through September 30th with 50% off on the ANSYS AIM annual lease license or paid-up license. Okay, so please feel free to check out our website regarding more information, or please reach out to your account reps at TriStar to get more information about these. We also have an offer on the PTC certified training courses, up to 60% off on virtual training through the end of this month, and also 36% off on the PTC MathCAD product also through the end of this month. So that said, from an agenda standpoint, like I said, I wanted to go over quickly just to a few slides on the importance of simulation going early in the product development process, and how ANSYS AIM's easy to use but still powerful user interface really essentially allows a simulation for every engineer rather than a specialized field like back in the days with a lot of training and a lot of complex learning curve, right? Or I should say longer learning curve to learn such an FEA tool. So AIM kind of brings the engineer or the simulation to the engineer's desktop, I would say, using those process templates. So you can see the image there wherein there are predefined templates for single physics as well as multiple physics, as well as you have the ability to create your own template. So you could be the CAE methods leader, and you could just have your design engineers, right? You could develop a best practice template for them to go through. You would be the expert that has developed this template, that have created you certain workflows for your analyses, and you can capture that and quite quickly and easily. And then if you can also edit them using some scripting if required, and you can save those and to be used by the entire design group, if you will, right? And like I said, towards the end we'll have a Q&A session. Please either type in your question in the chat or question area as I'm going through the presentation, and I will get to that towards the end. So first of all, when we talk about simulation-driven product development, right? You've seen. Let's take a simple example of the car here, right? So the simulation is used to design the B-pillar for structural dynamics, right, and crash worthiness, right? So those are the upfront that we normally analyze for before any type of instrumentation or any type of testing of a physical prototype, right? Before that, we need to do some structural dynamics analysis, right? Or even a fluid flow analysis, right? Like what we say, computational fluid dynamics, or CFD, is used to design the shape of the body, right, to meet some external aerodynamics and fuel efficiency requirements, right? There could be thousands of body shapes that are analyzed without even stepping foot into a wind tunnel, you see. So that's the advantage of doing simulation up front, right? And the electromagnetic simulation is also playing a crucial role for developing and verifying next generation, active safety systems, autonomous driving features, vehicle-to-vehicle infrastructure, or vehicle-to-vehicle communications, right? So what I'm getting at is, once you do those, then you might want to get inside the vehicle, wherein the modeling and simulations used to produce millions of lines of embedded software for the control systems and displays, right? As well as the design of the electronic systems itself, right? For maybe it has to meet certain EMI standards, maybe for proper cooling, right? So really what we're looking at is, in today's products, it need not be just a car like this. It's most of the products, you do have like multiple physics that you need to analyze, right? Each of the subsystems not only has to be optimized, but it has to operate perfectly by itself, but also has to operate in tandem with the other components in the system, right? So complete system simulation is used to ensure all these systems work together, right, meet the overall product requirements for performance, reliability, and safety, what have you, right? So that's really, we have seen more and more companies moving towards simulation-driven product development. I used to be an analyst myself during my industry days, and I've seen over my consulting days wherein simulation is playing a big role, right, in the product development process, especially the tools like ANSYS AIM that gives you an easy-to-use environment, the quick learning curve. At the same time, it has the power of ANSYS that we all know of, right? ANSYS is the golden standard in the analysis world, if you think about it, right? They've been there for several years. Now they've taken all that power and they've built a tool that's easy to use with very much guided workflows, process-driven templates, right? Now here a research, at the Aberdeen survey actually that was done on the importance of doing simulation and how it helps improve product development, right? So it's more to reduce costs, wherein when you allow designers and analysts to collaborate, or maybe even empower designers, other than doing their CAD work, to have them do some upfront simulation, wherein the experienced analyst, for example, could create a custom template or an application for the designers to use, right? So all he does, the designer would do, is provide some inputs and some boundary conditions. But as for the best practice itself, that's something that's developed, that has been developed in-house by the analysis group, and they can start using that for the design group with very minimal or very no or very minimal training, right? So, and the ability to combine multiple physics, like I said earlier, right? Most of the products these days, you either have, you want to test the structural performance of it, as well as the fluid flow, as well as the thermal performance, electric conduction, electromagnetics, what have you, right? So you're able to combine all this rather than learning or investing in multiple tools to get proficient at each one of these, and trying to import, export geometry into several different tools or applications, one for fluid flow, one for structural, one for thermal. You're able to do all that in one single environment, or I should say one single user interface. This is another thing, a trend that we are seeing over the last few years, and so years ago, if you think about it, people used to think simulation was saturated because it's too complicated, too hard to use, right? It's too computer intensive. We didn't have powerful computers back in the days, right? But currently, right, the goal, if you think about ANSYS, our goal is to, allow every engineer to do simulation to help your business with the overall product development process, save on time to market. So the idea is to solve the very equations on a massive scale, right? Rather than doing a hand calculation, allowing the software to do it. Now, back in the 80s, if you think about it, if the idea of every engineer should have a PC, right? And that could have been considered insane, but now it has turned out that way. Similar to that, we are foreseeing a huge, push for simulation for the engineers and the designers, right? Yes, granted, it's a complex tool, right? Most simulation tools are complex, but could it be just create some predefined templates so it's easy to use for anybody with some guided workflows, right? And with some inputs that the designer knows to apply. However, the best practice is something that's already bundled into the ANSYS AIM product, or something that you can also customize. And here's another metric on, you can see how important simulation, it's important to do simulation upfront at the concept, at the design stage to reduce the cost, right? You don't want to create your part, completely get it done, and then do a real world test, and then, do your rework or, start redesigning it, and then the amount of time on doing those changes to help with performance. You want to make sure that those go hand in hand or in tandem, right? So having seen, the importance of simulation, let's talk about what exactly is ANSYS AIM, right? If you think about, you might have heard of other ANSYS products, but ANSYS AIM itself is an integrated solution for 3D engineering simulation, right? It has the breadth and depth of ANSYS physics. So it has the power of ANSYS physics that we all know, but the user interface, right? It's an immersive user environment, right? Allowing you to do engineering simulation all from start to finish, all the way from editing model geometry, meshing it, the different types of meshes are supported, and then defining the physics, right? It could be single physics or it could be multi-physics, right? It could just be checking for heat transfer, analyzing for stress and deformation, or it could just be, to calculate, the mass flow rate, in the fluid flow situation, or it could be a combination of all of this. So they do have templates like fluid structure interaction, thermal, and structure interaction. And not only that, you can also run the what-if scenarios to do some design exploration, right? Once you find out the stress or the temperature or the output you get from ANSYS AIM, how are we going to improve it, right? Do we have to go back, change the design, redo the analysis, or could we make use of some design points and run some what-if scenarios, right? So all that can be done in one single environment. So really the bottom line is to provide every engineer with 3D engineering simulation, leveraging the CAD data that he's used to, exposing the parameters and the dimensions, at the same time giving him the power of ANSYS solver and its physics and its accuracy that we all have known all these years. So it's like you see a quick snapshot of the process templates there. That I know when you launch ANSYS AIM, that's what you get. You pretty much start with a template, right? And the template guides you through the workflow and the process and the steps, actually. So first you want to import geometry, right? Do you want to edit the geometry? Do you want to create the mesh, boundary conditions, results, solve the physics, and then the results? So it's really guiding you through that depending on the template you pick. Right, so it's really a platform for multi-physics simulation, at the same time allowing single physics. So you could be just doing a simple structural analysis, or just a fluid flow, just thermal, electric conduction. So all these little icons that you see here, all those are the process templates that comes out of the box, right here. Those single physics, you do have fluid structure interaction, fluid solid heat transfer, right, magnetics, etc., right? So, and you can create your own templates as well, right? You can also quickly create custom ones. Here's an example. If I were to select a structural process template, you get a workflow at the bottom. You can see there where it tells you, okay, the first thing is to get the geometry, then the mesh, then solve the physics, and then and then display the result. Now that is pretty straightforward. Now, in most products that you may be using, you're using multiple physics, which means you have to simulate the fluid flow first to get the force, right, from the fluid flow, and you have to do a structural simulation on that. So for situations like that, you are able to create this multiphysics workflow that you see on the screen, where I didn't have to create it. I just had to select fluid structure interaction. As soon as I did that, it kind of gives me, you see, it gives me, okay, first once you select the geometry and mesh it, you would do the physics for the flow, and then you get the results that's on, or you can directly ask it to go output those results onto the structural side, where it's using the mesh, or maybe you can control, you can do some additional mesh refinements, you can control that mesh density, right? There are some global settings or specific part settings you can control, and you can solve for the combined results there as well. So these are some of the advantages of process templates, right? Where you are not trying to learn a very complex system. Okay, what do I do next, right? I have this part model and I need to do a fluid flow. Do I open a different software to create my fluid volume, right? That's required for meshing, as you know. But ANSYS provides that to the geometry itself. You're able to do that in one single interface, right? It uses space claim design engine, right? I should say the space claim engine to create the fluid volume, and you can also edit the geometry, defeature, what have you, right? So it's just very easy to use. You just start with a mesh, obviously, right? And you can, all types of meshes supported, just like in the traditional ANSYS flagship products, right? Tetrahedral mesh, you can control the inflation when it comes to fluid flow analysis, right? All those settings, if required, you can change those. But out of the box, it gives you this default mesh, and then it solves for the physics, right? Once it solves the physics, you're able to view the results, as you can see there, right? So that's really a very simple workflow, and you can customize this and create your own application. So when we say geometry, as soon as I want to edit geometry, it takes you to, within ANSYS, you have this space claim engine working behind the scenes that's included in the ANSYS license, wherein you can create your fluid volume if you have to. You can defeature, you can edit geometry. So maybe you had a neutral file that did not have dimensions, right, like an ISO step file. You're still able to add dimensions or parameterize it, expose that dimension in ANSYS to create some design exploration. So you could see what happens if I change those input dimension values, and how is it going to affect my stress results or my any type of analysis results, right? So like I said earlier, you can get neutral files, and most of the popular CAD files out there in the market, they're all kind of supported within ANSYS. And it's also associative, so meaning you could update the geometry or make a change in, for example, Creo parametric, and you can update the geometry within ANSYS AIM, right? Or you can expose your dimensions that you have used in Creo. You can expose that within ANSYS AIM, or if it's not available for whatever reason, you're able to get into space claims or ANSYS space claim engine on the geometry editing tool, and then start adding some dimensions, or even quickly create this type of fluid volume, which is quite a difficult task in most of the CAD systems out there that are not focused on the CAE tools these days, right? And here is the multiphysics one that I was talking about earlier, wherein first you import the geometry, mesh it, and then you would apply the boundary conditions, right? Your inlet, outlet, right? And you would control the mesh if required, and then you would assign all the required boundary conditions for the fluid flow itself, and it runs through that single physics. At the same time, it knows to provide results or get the required information from the fluid flow analysis to the structural side, and maybe even do design exploration. So what you're seeing there, those grabs that you see, are the design checkpoints, or it could be dimensions from the CAD geometry, or it could be dimensions or parameters that you got from Space Claims editing tool, right? And so either way, you can expose dimensions and parameters and say, okay, these are my different design checkpoints, and I would like to see how are the results going to, and what is the impact on the results when you make those changes, right? Because it's a very important part of the analysis process, in my view, where once you're have answered the how much questions, the what if scenarios. It's very critical to make some engineering decisions on that product, right? You don't want to be spending time on going back, changing the design, redoing the analysis, and that's kind of a lot of loss of time, right? The whole point of doing simulation upfront early in the design process is to help you make that decision quickly, right? And that's when design exploration optimization plays a very important role. And this is also supported for all the physics types. You can configure when you install ANSYS. You are able to quickly configure the different CAD systems depending on what you've installed. I have Creo installed, so I could say that I want to have a CAD interface or Creo. And you can point to the location, and what that allows you to do is you're still running ANSYS AIM as a separate application. However, you could launch it from within Creo if required, or you can connect to an active CAD session. When you start importing your geometry, instead of importing, you could say, if there are any parts in my session, just bring that over and then start doing some analysis on it, right? So there are a few options. Create new geometry using space plane, or import existing geometry, right? Most of the geometry types, CAD files, are supported, or you can simply connect to an active CAD session if you have configured it that way. And of course, the ultimate goal of all this is, as you can see, I've exposed the fillet radius here from my Creo model, and I've parameterized it. So the whole point of parameterizing CAD dimensions is essentially creating a design checkpoint, right? Now, what we talked about so far was the out-of-the-box templates and the out-of-the-box process templates. But you can further automate using the customization tools. So that's, again, you can do with some scripting. It's pretty straightforward. If you have done this before with the other flagship products, you may have heard of ANSYS ACT, right, that allows you to create extensions on the flagship products. Kind of the same thing applies to AIM as well, where you can create, for example, I created an urban wind tunnel template, or an application that I've created there that I could just deploy to my design group and have them use it. You know, I might have used an existing design for that, but then, however, when they use it, I can just give them some standard inputs. I get to control what they see. I can really, edit the script because whenever you are using ANSYS AIM, by default, there is a file that gets created with all your actions and inputs, right? So that gets automatically saved, and you're just trying to leverage that and using that as an application for automation. So here's an example of a hip implant analysis application. So you see all the others, right? The structural, fluid flow, thermal, they're all standard out-of-the-box templates. But how did I create a template like this is I would run this once, right? Let's say I could be the analysis expert, or I could be from the analysis group, and I could run it once. However, for my design group, I want them to be running these on different designs, but I want them to use the same type of methodology or the process, right, on such designs. Instead of having them or training them to do this from scratch using a structural template that's out of the box, you could go create your own, right? So that's quite handy. You can even control what they get to see and what inputs they get to change, right? It could be material property, it could be loads, etc., right? So we're able to change that. So really, the way that it's doing that behind the scenes, if you think about it, it's using XML and Python languages, right? So if you're familiar with that, you can even edit those, right? And that's kind of how, in this example, you can see I have an internal flow, I have an electric field app, I have a hip implant analysis, and a wind tunnel app. So all these are actually even available in the ANSYS app store. You can go to your ANSYS website and you can even download these, but you can also create such application-specific solutions, which I think is huge when it comes to, because every customer's analysis and your products are different, and even though these out-of-the-box templates get you started, when it comes to new users, new designers or engineers that don't have an FEA background, I think this is huge, right? It's going to really help them, accurately get, do accurate simulation, get accurate answers, because that's very important, right? Just those color fringe plots are not important, right? You really need to get accurate solutions. At the same time, how much time or do you want to invest in training the entire design group that are very new to FEA? So this is when customizing the process template is going to be a big part. So when you start using ANSYS, right, if you use an existing template and you start applying loads, constraints, etc., it is ANSYS is saving, right? You see this journal file that you're seeing, it's actually saving all your interactions with the system. All we're doing is saving that as an extension and then loading that as an extension so that all users can use it, right? In fact, you can even edit that if you do, some scripting language, you're able to even edit that actually. Here's an example, right? By default, it gets stored, right, in the place where you store the project, right? It's still based on the Workbench platform if you think about it, and it stores under session files. So if I have to just quickly open up. So here it is, right? I have a folder where I saved my files. I have like a session file where you see this little, if I go to this and let me open that, journal file. So this is the file, right? So it's pretty much all that I did in setting up that model, right, including the physics definition, importing geometry. So you see what file I opened. So this is something that is happening behind the scenes, and we are just taking advantage of that to create that the custom template there, right? You can also, now don't think it's only for specific tasks and process within your simulation. You can even use it to create help files. Now, the hip implant example that I was talking about, maybe you have a new user that would like to know more about that process template that you created, and you can give him some additional inputs. As you can see, I have a little HTML instruction on where we apply the load, where we are constraining it, right? So it's giving me some additional information, and it looks like this is based on a certain standard. You can see it's based on an ASTM standard. So really, you're customizing not just the task, but also the help within ANSYS AIM based on your analysis best practices, right? Here's an example. As you can see, electrostatic field custom template, right, that defines mesh controls based on a target solution accuracy, right? So that's important. Remember, I told you, just getting a color cool fringe plot is not important, right? It's very important to get the accurate solution, right? So what type of mesh control should we be using? Couldn't I predefine that up front? So I don't want my designers or engineers to keep doing those type of pre-processing work. I don't want them to waste their time on that. I want to define it, right? I'm the expert. Let's define it, and let's have the others just use these quick, custom templates to get an accurate solution, right? On multiple designs really quickly in less time, right? So that's another example. Here's one for internal flow, right? Again, this is something that let's say your analysis group, you probably have a very highly experienced, some PhD folks that have been doing CFD for a long time, and they really know it in and out, and they're able to kind of set up this for you, right? The geometry and the goals, right? The symmetry, should I be using symmetry? The flow setup itself, right? What type of results are we going to look at, right? Do we need streamlines, path lines? Do we need mass flow rate? So all that can be defined in your entire, and it can be captured, I should say, into that template there, right? Here's a virtual wind tunnel application. You can see the help file there, right? So that's the football and flight, or it could be a wing aerodynamics right there. So, or even just a wind loading, for example. So all these, you can see how that's the virtual wind tunnel app. And again, many of these are actually available. If you want to try these out, and if you currently use ANSYS AIM, or you can even get it off of the ANSYS AIM on their website in the customer portal. You have this in the application store, right? And you can even start creating your own if required. And these are just a few examples there. So with that, let me see if there are any questions. So please start typing your questions in the chat session or the questions session. All right, looks like there are no questions. Just to remind you before we wrap up here, you have a chance to get that 21-day free trial license of AIM with full support from ANSYS experts. All right, so please, if you want to get more information about that, please visit our website there regarding this time-limited offer, or please reach out to your account reps at TriStar. And also, just a reminder on the promotion that's ending through this month on certified virtual training, as well as on the MapCat product. Some good, you got some pretty good savings on those to the end of this month. All right. Looks like there might be one question that came up. Okay, there's one question here. Is combustion simulation with thermal stress analysis possible? Yes, you should be able to use that. I think I'm not positive on that. The fluid structure, simulation. All right, there's a template for that, or you may have to create. I'd say you start with that, and you might have to create a new, or I should say, a custom template for that, but it should be doable. All right, so with that, thanks for all your time here. Please, check out our website that has, this is the third webinar we are doing on the ANSYS product. So if you would like to get a lot more overview with some more examples where I've done a demonstration of all those single physics and multiphysics, please, at TriStar.com, if you go to the Resource Center, you do have our recordings of our past webinars. This webinar, we wanted to just focus more on the ability to do custom templates and also the ability to use existing default process templates. We look forward to seeing you all soon in another webinar shortly. Until then, thanks and have a great rest of the week.